Okay. So yeah, so as per as you can see in this scene that we'll be coming across the main topics here. The first thing is air defense, that is the Indian air defense, which we'll be looking through how things go in the air force, how the missiles are working. So we'll be looking into that. How then comes the purpose, the function of the control and the guidance system. That is basically how we can control the attitude or the flight path of the missile. Then also we'll be looking into sensing technologies, to sense the thing to, or else how to detect an object. All so we'll be learning about that. Then the phases of the guidance, that is from the initial to the final terminal phase, we'll be understanding that. Then the control guidance missiles, the homing guidance missiles, the self-contained guidance systems. So these are the guidance systems which will be taken care by John. So first I'll start with the first foremost thing, that is the Indian air defense system. As you will know, as we all know, that Indian air defense system is one of the most powerful system and the most powerful defense system we have in this world. So let's see how things go in this. The first thing which works here is the multi-layer air defense system. So what it is, the word itself shows us that it has multiple layers of air defense, because to cover the whole, to cover the country, it is very important that the you have to maintain the defense, and you have to maintain everything at at a particular range and distances. We cannot act counteract just before the missile or a threat is coming towards us. We have to be very prepared. So basically, so as you can see, there are equipped with all the long. We are, as you can see in the PPT, you can see that Indian Air Defense has a lot of protection in terms of long range and in terms of short range. Starting from thousands of kilometers to hundred of kilometers, there are separate layers which are helping us to protect against our enemies. Okay, so if I say, John, can you move ahead? We can show them the diagram so that it gets us easy. Okay, so you can see here the thing, if you can see in the PPT, that there are circles which are highlighted. So basically these are the multi layers. Okay, these are the units if you see, but then just for the information, that these are only for the referral part. This is not the actual range. We do not know how things go, like how what is the actual range or how is they covering. This is just an example, and we are not bleaching into any of the security systems. Okay, so if you can see, these are the layers. One layer, if you see, these are the near the borders where we have been into more of the threats, that is near Pakistan and China, where mostly there's high security. If you go ahead deep into these circles, we'll understand the layers. As you can see here, this is the first layer. As you can see, that is the long range, that covers around 5,000 kilometers. So basically, these are the missiles like Prithvi, which are used at long range interceptions. So these are like Indian. Here, the Indian ballistic missile here defenses are kept in the accountant. So basically, if you want to cover 5,000 kilometers, so what we do is we use this kind of insights. We use such kind of missiles for 5,000 kilometers. Like for example, if a missile is coming from Pakistan or China or any other country, so first Prithvi will be there, which will be launched, and then to destroy it at the utmost, at the entry level only. Then comes the 2,500-kilometer range, which is basically intermediate range, where the interception missile which are used is mostly S-400 Triumph, which you can see here. These are these are used if the if there is a missile which is launched just near to around 2,500 kilometers from the target. There are next comes the missile which is around short range missiles, that are Akash, and also there are similar kind of defense missiles which are used. So here the things like it's just below, if the target which is just beside the boundary or the borders, it is when there are people who, there are times when countries just uh, you know uh, launch a missile just beside the borders. So this is where our short range interceptions will help. And the most important here is the line of sight, that missile, which is very short range interception, where manpads and anti-aircraft guns are used. So to give a exact idea, if you guys have might have seen in the movies that the action heroes uses bazooka. So these are the kind of missiles which are man-made, which are launched from the ground, and which you can just hit at the line of sight. I hope this is clear and I'm not going fast, right? Okay, so let's move ahead. That Okay, so the most important point about long range interceptions are, there are basically two different there are four missiles basically, but which are kept, two in the land and two in the water, in the sea. Okay, so here, the first, like higher altitude interceptions, the Prithvi air defense system. These are the ones which are, used at the foremost thing, as we were discussing. These are launched from the land, so that once it releases, it hits the target, and it destroys it at earliest as possible. But then there are sometimes there are problem. There might be an problem when the target missile is pretty fast, or maybe it is designed in such a way that it has to overcome the speed of Prithvi, or it has to dodge itself from Prithvi. So if it comes out of the range of Prithvi, now how are we supposed to get? So here there are advanced air defense systems for lower altitude. For example, if Prithvi is unable to hit it, so now this missiles will able to hit it and will be safeguarded from the attack. So this is why advanced air defense systems required at the lower altitudes. Okay, so let's just go ahead. Okay, so we have been hearing that these are the interception missiles and these are the target missiles. So what is the interception missile? So everyone knows that interception, the meaning of interception is the same. It's the one which has all the features to destroy a missile. It, like when I say all the features, it will be having a lot of equipments which is related to radar, camera, sensors, anything which will be related to that, so that it detects, it finds the exact target and the enemy missile, and then it can hit. Whereas in an enemy missile, there will be only few things that will be there, that is equipped by supported by fixed GPS targets. Because the only motive of the enemy missile is to hit the target and hit the destruction. Whereas the interception missile are responsible for getting the defense, to defend it from getting hit. So it has to calculate each and everything, it has to measure each and everything, so that it hits at the correct point. So to get it better, let's see how interception missiles work. So I hope you see how you got an idea how interception missiles got. This is basically uh, this is this is the best we can explain you that how interception will be working. It's just that it has to calculate all the path, all the proper calculations should be there, so that it hits the missile enemy. And if it misses out, there are low altitude missiles, or else the assets and the public are distracted. Okay, so let's go ahead. We are done with the interceptor missile. We understood. Now let's study the purpose and the function. So what is the purpose? So if you see, the most important, and most of you might be understanding, the thumb rules. Jan, can you move ahead? Yeah. So you can see this is the altitude control, and the picture shows the thumb rule. If you know, there's a left-hand thumb rule which we studied. It's kind of same. The first x-axis where the x, y, z, where we'll be looking into yaw moment, pitch moment, and roll moment. I hope you guys know what is pitch, yaw, and roll, right? So these are the axes how these are used in flights, used as per the flight it has been shown. So longitudinal is for roll, the lateral axis for the pitch, and the vertical is for yaw. Okay, so this is the basic idea how the altitude works in the flights. But as per when you go into missiles, the thing common here is the roll. The roll will always be in the y direction, but the pitch and the yaw, which are in x and z coordinates, that is very important. That these are in a symmetric way, in a perpendicular. So we do not know, like, as you cannot determine the axis of pitch and yaw by looking at it. Yeah, so it can be only determined by the people who knows about the lateral and vertical accelerometers. So they are the one who can actually understand which is the actual direction they are working on. Okay, so this is the most important thing of a missile, because as per when you see, it will be only in one direction. Like it is completely symmetric, and the roll will be in the y direction. Okay, I hope you guys are getting what I'm trying to convey, right? Okay, John, let's move ahead about. Okay, so what is an altitude control? It is basically, it is used to damp or remove the fluctuations or anything which will deflect a missile from its original trajectory or original path. Okay, in order to keep all these things in proper alignment, in proper path that is fits your role, to keep it proper according to all of these three axes, it is very important that you have to make it proper. So that's the reason why altitude control system is being used. Okay, if a missile becomes there are three things we'll be discussing now for an altitude. Okay, okay, so basically for a stability there are three different stability that come into picture. First we'll understand, then we'll see what is dynamic instability. So first is the positive stability. For example, you release the missile and there's a disturbance which you have given to it. Now the missile will go to unstable mode where it is, because you have given a disturbance, and now slowly it will try to come into the stable mode. So after going into instability, it will now come into stable mode. Okay, so this is called as positive stability. Okay, then comes the neutral stability. What is neutral stability? When you give a disturbance, when you give a certain amount of disturbance, okay, the missile will change from stable to unstable in that amount, the amount which you have given. So now it will continue to move ahead with that amount of instability. So it doesn't come to the normal, that is stable position, and it doesn't create more instability. It is at the same amount that you have given, the same disturbance amount which you have given. So now it will move ahead with the same amount of undisturbance. So the same amount of disturbance with the instability without having any other changes. So that is neutral. And the dynamic stability which I'm talking is when you are, when there is a disturbance that has been given, and after the disturbance which is provided, so from stable it comes to unstable, and then the instability increases and it doesn't come to the point. Now it goes on increasing. So that is where this is where it is said it is dynamically unstable. So to control it from that position, it is very important that we have a good connection from the ground as well, so that it doesn't go out of the hand, like out of your way. So it's very important. So let's come into flight path control system, how it is determined. So if you see the flight path that is in green color, the first flight path with the milestone one, which you can see, that is the arrow mark. If you see, it goes, that is the determined path which we have selected. That is from 1 to the 2, 3, 4. If in case, if you see the flight path, these are the trajectory, that this is the path he should decide. If there is a problem in the path control or there is instability, this undesired path will come into picture and it will disappear. You will see this. Yeah. So this is the undesired path. If you follow this path, you don't have to, this is the path you should follow, or this is the path any of the object has been given to, or else this undesired path can lead, or we can go into undesired path, which will create a further problem, and it can also lead to any destruction. So it's very important that a system should follow that flight control path. Okay. So let's move ahead. Okay. So it is very important, as we discussed, very important to, to walk on the path as per the decided, like to work on the targeted path, because if you lose out to the path, then you will not be able to hit the target. So the target interception to is very important that it follows the path. Okay. And if you do not, then it can lead to mission failures, as you can see. So this is very important aspect of any missile or any related any object which is into defense or at defense. So now let's understand what are the sensing parts. Okay, so we'll do one thing. The word sensing itself, we know that it's to understand, to find out, to collect the information about anything or everything. So how we smell, we taste, it's same thing. A missile has some equipment, some abilities. There are there are features which has been inbuilt to sense and go ahead. Starting with the accelerometer, it is to sense the pitch yaw roll that has been used. So it is very important for that. So it is used to guide it properly towards the enemy missile. Then comes the long range navigation system, which is a transmitter basically, where which will be transmitting, which is used for the communication. There comes the celestial references. It is very important that, see, you cannot always expect a war at the afternoon time when you can see everything. No, there are wars in the night, there are wars anytime. So people, the defense systems use celestial references. When I say celestial references, it can be sun, or it can be the north, the the stars. Each and everything can be determined. So basically they use the stars or the sun to find the way. There are also a lot of star trackers which are being used, where they follow the stars and the coordinates dependent on them. So the missile will be following towards it, and then it finds the target. So they use the celestial references. Even there are missiles which use Earth's magnetic field to determine where it is and how things go there. And ahead, when I say this is the television, I'll say this is not a television where you know where there are video, like not the normal television. It's basically there is this this is the television placed in the missile, where there'll be images of the target. So when a missile will be going over certain things, just go behind, John. 1 second. I'll just finish it up. So when the missile will be going towards a target, it will see the target, and it will match accordingly, and then it will decide, okay, fine, it's the same place we are looking for. So now it will be going to destruct. Then it was thermal. I don't know where is John, and he's not using it. Okay. So there are thermal sensing to use the temperature. A missile will be having larger temperature than the atmosphere. So it is easy for the sensors to understand this is a missile, or this is basically the target. There are radar, there are cameras, there are radios which are used. Or these are the basics which are used in every sensing technologies. Moving ahead with the thing, control and actuators. There are four things you can see: thrust vectoring, fin control, fin grid control, attitude control. Okay, so what is a thrust vectoring? Thrust vectoring is to direct the thrust of a missile, to make it align, to make it work or fly towards a certain to follow the path. If I say, John, are you there? Hello, is John here? Yeah. Okay. So this is the thrust vectoring picture which you see. That is the center line. This is the thrust line. If you see, so when a missile is launched, okay, the nozzle moves around so that it comes to the position or it turns. It there are side changes that takes place. So to change the direction of the vehicle, it is very important that we take care of the thrust vectoring. Okay, let's move towards the second. John, can you change the slide? Yeah, that is the fin control of a missile. Okay, so when I say fin control, you might have seen in the flights that there are fins attached. Okay, so when you see while taking, when if you have seen, if you have sat in a plane and you see seen through the windows that whenever there's a takeoff, the wind here, the fins will be going up and down. This is to create the drag and to get the speed of it. So there are also such fins available in the missile to get to give it a drag or to increase the speed. So just go ahead, John. Hello. Yeah. So this is an interesting grid fin control system where you will be seeing a lot of things. You will be seeing this in mostly Falcon 9. They have introduced this mostly, which moves up and down, from the like perpendicular to the ground. So it will adjust the missile accordingly. While if you can see the degree grid fin angle, and this is the reference line, the green color. So when there's air inflow, okay, so as per the air inflow, the missile grid fins will be moving up and down. This is the basic idea how Falcon 9 is using. So moving ahead, this is the kind of grid fin control. John, can you move ahead? Yeah. So these are the thrusters which are used. If you have seen a few videos about how this is a kind of thrusters that are attached in all the directions to make it stable. You might have seen such videos related to thrusters which are used so that the attitude is controlled. It doesn't move here and there. So it releases in all the XY directions. Okay, let's start with the phase of guidance that will be taken care by John. John, can you come? Okay. Uh, Hello, John. Are you here?
Yes, Devashish, I'm here only. Yeah.
Yeah. Can you take ahead with this?
Yeah, sure, no problem.
Okay. Thank you. So I hope if you guys have any doubt, you can ask anything. You can ask your doubts in the end in the chat box. We'll be happy to answer all the questions if there's any doubt. Okay. Over to you, John. Yeah.
Yeah, thank you, Devashish. Okay, just someone can prompt me. Am I audible? Hello? Hello? Okay, yeah. Thank you.
You are.
Yeah, okay, thank you, Devashish. Okay, so now we'll be talking about the phases of guidance. So there are different phases. Phases basically mean, the different levels or different distances or different sectors when a missile is traveling from one location to another location, that is from the launch point to the target point. Okay. Now, talking about the different phases, we have three phases basically. The first one is boost phase, the second one is the mid-course phase, and the third one is called terminal phase. Okay, now here's a overview of how it looks, but we'll talk in detail after this. Okay, so now coming up to the boost phase or the launching phase, or we also call it as initial phase, especially Navy missiles. Because why we use boost phase, you would have seen there several rockets, or you would have seen even the GSLV rocket, the geosynchronous launch vehicles. They have the booster straps, the small rockets attached to the surface of the main missile or the main the main rocket. Okay, they're basically used for accelerating the flight. Because see, let's say a missile is being launched from a submarine or from a ship. Therefore, it needs a lot of boost to come out of the missile, come out of the submarine, or come out from the water, and then take a launch and go to its target. Therefore, so that to reach up to the optimum height, basically, from where a certain height should be reached from where the missile can see its target, and there's no obstacle in between. To make the missile reach from its launch point, whether it can be a ship, it can be a submarine, ground, anything, from that point till a point where the missile camera, missile radars, missile sensor, anything can easily see, detect the environment around. Now this particular phase from where launch point to a point from where everything is so good in terms of looking up to the target, that phase is called as the boost phase. In this particular phase, the guidance and aerodynamic surfaces are logged. Why they are logged? As they was talking about the aerodynamic surfaces, they can be grid fins, they can be simple controllable fins, they can be attitude thrusters. They all are logged for a specific position, and that is mostly straight up vertical. Straight up vertical, you would have seen missiles are launched straight up vertical up till a height, and after that they take a turn, they take they change their attitude and move to a certain direction. Okay, so that phase from where it's going from launch point till that point where it actually takes the certain direction, that much phase is called as the boost phase. Okay, now coming to the mid course phase. Now mid course phase is actually the longest phase in terms of distance and time. Once you launch the missile from your launch point, it goes up in the air to a certain specific place from where it can take a, it can see everything clearly, and then it can change its attitude according to the target or according to the location for where it is fixed to go. On that basis, it takes a certain direction. Now, on that particular direction, it travels up till it reaches a point from where it can see the target actually. You would have seen the missiles cruise, especially the intercontinental ballistic missiles, the ICBMs. They are exo-atmospheric missiles. They launch. The boost phase is so long. They go out of the atmosphere and they travel a complete continental distance. And then when they are about to reach their target, they descend down. Okay. Now this phase from where it has started traveling, the final altitude is set until it starts seeing its target. That distance, that phase is called as mid-course phase. Now, mid-course phase is specially designed to bring the missile onto the desired course, and also it is made sure that it remains on the course, keeps it maintained. Now, mid-course guidance system is used to place the missile near the target, especially when you have an intercontinental ballistic missile traveling from one continent to the other continent. So it is specifically made that the missile reaches near the target. That much phase is mid-course phase, and after that, the terminal phase comes up. So we'll see what terminal phase is. In terminal phase, there's need to be high accuracy because terminal phase is the most important phase and the most fascinating phase as well. Because why it is the most fascinating phase? Because it has got a lot of guidance system that locks it onto the target so that it can go and hit the target with maximum number of accuracy. There is no too much amount of time. There's a huge acceleration and the target can be moving as well. Therefore, it must be very extremely fast response. There should be extremely fast response to any kind of the guidance signal. Apart from it, the missile in the terminal phase should be able to execute the final maneuvers. Because see, when a missile is traveling at a very high speed, the maneuvers become small maneuvers. Like, okay, let's take an example. Your domestic air flight, okay, let's say Airbus A320. If it's flying and you give 1 degree, even 1 degree of change in the roll movement, or we call it as your ailerons. So even if we give a change of 1 degree in your ailerons, the flight, you can actually practically see the movement in the complete aircraft. But coming up to fighter air jets, okay, in fighter air jets, at the speed at which the Boeing or Airbus A320 travels, if at that speed you give 1 degree of movement, you won't see any kind of change, because the control surfaces are far smaller than A320 and are not made to give the complete effect, and are not made to give the exact amount of change in roll, pitch, or yaw for 1 degree of change in aileron, or it can be pitch control or yaw control. So it should be able to execute the final maneuvers as well, because there might be the case where your intercept is forever changing, or the target missile has changed its path, or if it's a surface to surface missile or air to surface missile, the surface target is moving throughout, let's say an example of tank. Now, as fast as acceleration will be, especially of the target, let's say the target is moving all around, the method will become of terminal guidance, because the missile has to detect that how fast the system is moving, and it should be accurate to hit it up. Now, these are the three phase. The first one is your boost phase, the second one is mid course, and third one is terminal phase. For all these phases, for short range missiles, small missiles like Akash and Prahar, these kind of missiles are basically have they basically are incorporated with a single guidance system for all three different phases. But for long range missiles, especially for the long range interceptions like 5,000 kilometers and more, as Devashish was talking about, they have different kind of guidance system for each phase, so that in case of failure of a single guidance system, other two can take over the system and the accuracy remains as it is. Okay. Now, by this time, you already know how missile can be guided. As we were talking about the fins, we were talking about the attitude control thrusters, the grid fins, and along with that, the thrust vectoring of the nozzle. Now, these are the methods how missile can be guided. And now you also know how many phases are there of different missiles, the path of the missile. Now we'll learn how to command these guidance, and along with that commanding the guidance, we must know how the intercept is detected, how the on target detonation happens, and what different kinds of missiles are there. Because you might have heard about the missile is actively homed, or it's a homing missile, homing guidance missile, it's a surface to surface, surface to air, air to air. There are various categories. So we'll talk categorically about each and every kind of missile. Okay, now there are different kinds of guidance system. You know how it can be guided. Various control methods are told, but how they are actuated, how the command transfers from your computer, your ground station, to that particular fin, to that particular grid fin, or to that particular, uh, you know, nozzle control, thrust vectoring, or the attitude control thrusters. Now there can be two guidance systems. The first one is man-made electronic devices that can be used to guide a missile, or the other methods can be using the electromechanical devices. Sorry. So there's a difference between both of them. Now, when we talk about man-made electromagnetic devices, they can be radar, radio. So you can simply understand if you are controlling it from ground. So it can be something like electromagnet device, because it can be a radar, radio communication, a radio transmission, just like you control your small drone. I mean, that's a high level technology, yet just explaining in the usual terms. Coming to the second category, that is missiles guided by other methods, they can be electromechanical devices. In that also, there are two different kind of system, that is self-contained guidance system, and the second one is hybrid guidance system. But we won't be talking about hybrid guidance system, because it's way beyond the scope of this seminar. Okay, now talking about the first category, I just want to clear up the index again. There are two different guidance systems. One is